Imagine observing a glass shattering on the floor, only to witness the shards magically reassembling themselves, or watching the smoke from a cigarette being sucked back into it. Strange, isn't it? Welcome to the mystery of time. We are all passengers on this one-way street, constantly moving from the past towards the future. Yet have you ever stopped to ponder why time only flows in one direction? In our everyday life, certain events only happen in one particular order. Take, for instance, a ripe apple falling from a tree. It's a common sight, agreed? But have you ever seen an apple spontaneously fly up from the ground and attach itself back to the tree, becoming unripe over time? Probably not. These are illustrations of what physicists call the arrow of time, a concept that time has a clear direction, from the past, through the present, and into the future. This directionality of time is deeply embedded in our universe and in our human consciousness. Interestingly, almost all the fundamental laws of physics don't care about the direction of time. They work just as well backwards as forwards. If you were to watch a game of pool in reverse, the balls would move according to the same laws of physics, just in a different order. Yet, we never see this happen. So, we're faced with a conundrum. If the laws of physics can work both ways, why does time have a preferred direction? Why can we remember the past but not the future? Why are we always getting older and not younger? These questions lead us to explore a fundamental mystery of our universe, the arrow of time. It's a journey that takes us from the familiar world around us to the very boundaries of our understanding of the cosmos. So, buckle up for a fascinating exploration of the most elusive dimension, time. We will delve into the heart of this mystery, guided by the laws of physics, the wisdom of philosophers, and the insights of cutting-edge scientific research. Why does time only flow one way, from past to future? Let's embark on this journey to unravel the enigma that is time. To answer this mystery, we turn to a powerful player in the game of physics, the second law of thermodynamics. It's a fundamental rule that governs our universe, and it's all about a concept you may have heard of: entropy. So, what is entropy? In simple terms, it's a measure of disorder or randomness. The second law of thermodynamics states that the entropy, or the level of disorder, in a closed system like our universe, always increases over time. It's like an invisible hand, constantly nudging things towards more chaos and less order. But let's break it down a bit further with an everyday example. Imagine a hot cup of coffee. You can see the steam rising, feel the warmth radiating, and if you wait long enough, you'll notice it cools down. This process is irreversible. You never see a cold cup of coffee spontaneously heat up and steam on its own. This is entropy in action. The hot coffee is a system in a state of low entropy. It's organized, concentrated heat. But as time passes, the heat disperses, spreading out into the cooler room. The system becomes more disordered, and entropy increases. And this doesn't just apply to coffee, it's a universal principle. Whether we're talking about the formation of galaxies, the burning of a star, or the aging of living beings, the second law of thermodynamics holds true. Entropy, or disorder, always increases over time. This law gives us a hint to why time seems to only flow in one direction. It's because the universe is on an unstoppable march towards increasing disorder. But the question remains, why is the universe like this? Why does it favor disorder over order, future over past, time flowing in one direction over the other? Entropy, or disorder, always increases. And here's why it matters. It's not just a law of physics, it's a fundamental clue in our quest to understand the very nature of time itself. So let's dive deeper into this fascinating enigma and see where the arrow of time leads us. Entropy, in its relentless pursuit of disorder, ties directly to the arrow of time. This fascinating connection reveals one of the universe's most intriguing mysteries. But what does it mean? How does entropy, a measure of disorder, link to the one-way flow of time? Let's think of a puzzle. A completed puzzle represents low entropy, or order. But if you mix up all the pieces, you've created a state of high entropy, or disorder. Now imagine if the puzzle pieces could move on their own. Over time, they're more likely to arrange themselves into a state of disorder simply because there are more ways for them to do so. This is the essence of entropy. It's a statistical law. Now let's connect this to the arrow of time. Imagine you're watching a movie of the puzzle pieces moving. If the pieces start in a state of order and end up in disorder, you'd say the movie is playing forwards. If the pieces start in disorder and end up in a state of order, you'd say the movie is playing in reverse. This is because our universe has a natural direction of time from past to future, from order to disorder. The increase of entropy gives time its arrow. But what gives entropy this peculiar property? After all, most other physical laws don't care whether time is moving forwards or backwards. They're symmetric in time, but entropy isn't. In a closed system, like our universe, entropy cannot decrease on its own. It always increases, or at best remains the same. This irreversible nature of entropy gives time its direction. So, there you have it. Entropy, in its quest for disorder, creates the arrow of time. It's a subtle yet fundamental aspect of our universe, governing everything from the cooling of your coffee to the expansion of galaxies, and it's all thanks to the second law of thermodynamics. But why does entropy matter? Let's explore some theories. Scientists have proposed several intriguing theories to explain the arrow of time. Let's dive in and explore some of these. One of the most prominent theories is the Big Bang theory. It suggests that the universe began in a state of very low entropy. As time passed, entropy increased, leading to the current state of the universe. This continuous increase in disorder created the arrow of time, pointing from past to future. Just like a movie of the universe playing from start to finish, you would see a progression from order to disorder, from the Big Bang to the present day. Next, we have the psychological arrow theory. This theory proposes that our perception of time is rooted in our memory and our understanding of cause and effect. We remember the past but not the future, and we perceive effects following causes. This creates a psychological arrow of time that matches the thermodynamic arrow. It's a compelling idea, isn't it? Our very perception of time might be entwined with the laws of thermodynamics. The last theory we'll discuss today involves the mysterious black holes. Some scientists speculate that these cosmic entities play a significant role in the arrow of time. The idea is that when matter falls into a black hole, the information it contained is lost. This loss of information could contribute to the overall increase in entropy, further solidifying the direction of the arrow of time. Each of these theories brings a unique perspective to the table, offering potential answers to why time only flows one way. They paint a picture of a universe that thrives on disorder, where time's arrow is drawn by the invisible hand of entropy. Yet, despite these fascinating theories, the mystery remains unsolved. The arrow of time continues to be one of the most intriguing puzzles in the realm of physics, a testament to the endless wonders of our universe. The debate among physicists continues. We're still seeking to fully understand the reason behind the arrow of time. As we delve deeper into the complexities of our universe, we find that time is a tantalizing enigma. The arrow of time, the direction in which time flows, remains one of the most hotly debated topics in the realm of theoretical physics. Scientists around the globe are tirelessly working on theories and conducting experiments, hoping to unlock the secrets of time. They are asking questions like, why does time have a direction, and why does it always move towards increasing entropy? Theories abound, each shedding a different light on the arrow of time. Some scientists propose that our universe began with a state of very low entropy at the Big Bang, and since then, entropy has been increasing, creating the arrow of time. This theory, however, raises another question. Why did the universe start from a state of low entropy? Others suggest our perception of time might be based on memory and cause and effect. We remember the past, but not the future. But does this mean the arrow of time is merely a psychological construct? Then there are theories that involve black holes, suggesting that information lost within them might contribute to the overall increase in entropy. But these theories are still in their infancy and require further investigation. The quest for answers leads us to even more questions. For instance, does the arrow of time point in the same direction everywhere in the universe? Could there be places where time flows differently? These questions, while they might seem perplexing, are what drive scientific exploration. They push the boundaries of our understanding and inspire us to keep seeking, keep questioning. The beauty of science lies in its perpetual quest for knowledge. So as we continue to unlock the secrets of the universe, we can be sure of one thing: the investigation into the arrow of time will continue. So, does the arrow of time point in the same direction everywhere in the universe? Could there be places where time flows differently? The investigation continues.